So we received BucketSort as our sorting algorithm, and to start we'll be going over how it works. So to begin a bucket sort, you're going to make 10 buckets labeled with indices 0 through 9, and each index will have the potential to hold multiple values. So essentially it could become a linked list, and that's just useful to keep in mind based on how this sorting algorithm works. So then, given a list of numbers, you're going to go through each number, starting with their least significant digit, and then placing each number into the bucket associated with its least significant digit. So for example, given this list, 68, 888, 421, 0, 54, and 393, these numbers will be sorted based on their least significant digit, so the digit on the right. 68 will go into 8, 888 will also go into 8, 421 will go into 1, 0 and 0, 54 and 4, and 393 in 3. So essentially, the least significant digit is becoming the index into the bucket array. And then again, if there is already a number at that bucket index, you're just going to continue to place each following number with the same least significant digit at the end of that bucket's list. So again, in 8, you see that there are 2 values, so it becomes a linked list with 68 being the head and then 888 being the next node in that linked list. After that, you're going to remerge the list based on the bucket array created in the last sort, and then you're going to repeat the last step for each number's second least significant digit. So the last sort created the bucket array of 0, 421, 393, 54, 68, and 888, and then you again are going to repeat the last step, but based on the second least significant digit. So 0 will go in 0, 421 will go into 2, 393 will go into 9, 54 will go into 5, 68 will go into 6, and 888 will go into 8. And then it's important to note that if a number doesn't have another digit preceding it, you're simply going to replace it with a 0. So since 0 doesn't have any other significant digits to it, you're just going to replace all the values next to it with a 0. And then finally, you're going to keep repeating steps 2 and 3 until the largest number's most significant digit is hit. So since in this list, the largest number only has 3 significant digits, you're only going to sort this list 3 times. The last sort will look like this. So based on the bucket array created, this list is 0, 421, 54, 68, 888, and 393. So then 0 is going to go into 0, 421 into 4, 54 into 0. And again, since it doesn't have a third or most significant digit, a 0 goes in front of it. So that's why it is at index 0. And then 68 also goes into 0 for the same reason. And then 888 into 8. And then 393 into 3. And then you should have a sorted list.
A special, unique, way cool fact about the bucket sort algorithm is that it is a non-comparison based sorting algorithm. And what this means is that we never compare 2 values to one another. All that the algorithm is doing is placing each number into a bucket based on the value at a specified index, which means no comparison is required. And I think that's pretty interesting. As for the running time for this algorithm, it is O of n times k, where k is the number of digits in the largest number. This makes it very good for sorting lists with many numbers as long as they're relatively similar in the number of digits. For example, this first list, all of them have 3 digits, which means it would be very efficient in sorting this list of numbers. What it would not be good for is sorting lists where one number or a few numbers are significantly greater than all of the rest. And for example, we have a list of 3-digit numbers, except for one, which has 11 digits. And it would not be efficient for this because it would have to go through each digit of the largest number, even though it is clearly larger than the rest, and it's just wasting time altogether. As for the algorithm being stable, it is. The algorithm is stable because if there are two identical values in an array, the order in which they appear will not change because they will be sorted into the same bucket each time. And as for the algorithm being in place, it is not in place because we have to allocate memory for each of the buckets or linked lists per index, as well as the count array to keep track of the index we are on.